Hi everyone, welcome back to Learning Kotlin Live. This is wait a moment, let me first check if, this is the episode 24th, and let me first check if I'm online. Yeah, I'm online, okay. So, today we're going to talk about more about, Kotlin. So we were at basics and we were at return and jumps, which pretty much is, I think we have covered most of the items in basics, so I'm not going to repeat them. Even some we didn't explicitly introduce some of them, some of these pages. And we were at data classes yesterday, so the day before yesterday. So maybe we can take a look at sealed class today. So sealed classes are used for representing restricted class hierarchies, which when a value can have one of the types from a limited set, but cannot have any other type, they are in a sense an extension of enum classes. Okay. The set of values for an enum type is also restricted, but each enum constant exists only as a single instance, whereas a subclass of a sealed class can have multiple instances which can contain state. That's a little bit complicated. To declare a sealed class, you put the sealed modifier before the name of the class. A sealed class can have subclasses, but all of them must be declared in the same file as the sealed class itself. Okay. So we have a sealed class which has the name expr expression. A sealed class is abstract by itself. It cannot be instantiated directly and can have abstract members. Sealed classes are not allowed to have non-private constructors. Make sense? Note that classes which extend subclasses of a sealed class, indirect inheritors, can be placed anywhere, not necessarily in the same file. Okay. The key benefit of using sealed classes comes into play when you use them in a when expression. Okay, that's why we said that we treated it like an enum. So constant and sum, they are all data classes that extend from expression, which is a sealed class. So they are both expressions, but a sum is definitely not a constant. So we can then write this when expression constant, and if there is a constant and it is a sum, then we do something, not a number, then blah blah double dot none. Evaluate expression dot e1. Where does that e1 comes from? Okay, sum of two values, so eval expression 1 plus eval 2. Okay, so basically if we want to use it another way, we could have a planet, sealed class planet, and data class Earth, data class Jupiter, or those sort of things. Well, I haven't taken a look at object yet, right? Yeah, object is something that would comes into play later. Let's take a look at generics. Okay, this is super intensive. I don't think my mental status is ready for this. Yeah, let's keep it today. And let's take a look at nested classes. So classes can be nested in other classes. Of course, this is also something we can do in Java. Class outer and class nested, which this is an inner class. And in Java, I think we will need it to be private, or it can also be public actually. So it can be either way. And it is if it is static, makes big differences. So it seems to me that the nested class is static, just like the static nested class in Java by default, because here it says if a class is marked only when a class is marked as inner, then the inner class will be able to access members of outer classes. So inner classes carry a reference to an object of an outer class. That definitely looks like the how normal inner classes work in Java. So C qualified this expression to learn about ambiguous of this. Oh, this is also we have read this already. This is just like the I think it needs some at, or I mean the class name. This expressions other, okay. So yeah, it needs a list at. Oh, it's actually qualified or labeled. Okay. We need to name it this at A or this at B or this at where's that foo? Okay, A, B, and foo. Really? Implicit label at foo, and that's a function. So that's foo's receiver. I don't really get this explicitly, but anyway, this is talking about the qualified list. So yeah, it's about labeled lists. Anonymous inner classes. And we can create anonymous inner classes with this object expression. And this is just like the new sum class expression and Java. That's anonymous inner class. If the object is an instance of a functional Java interface, you can create it using a lambda expression prefix with the type of the interface. Listener equals to action listener versus action listener. Anyway, it seems like this is the only function, the only abstract function that action listener has, so we can write it with the way lambda. Write it in a lambda way. Enum classes. Also, actually, there is a enum. So what's the difference between enums and sealed classes? That's weird. I thought sealed classes are the enum classes, but they are not. Let me take a look at it. Sealed classes are used for representing restricted class hierarchies. Yeah, that sounds like enum to me as well. When a value can have one of the types from a limited set but cannot have any other type. Yeah, so expression is either constant, sum, or not a number. What about enum? Okay. Here's a type safe enums. Each enum constant is an object. It keeps talk about objects, but objects is actually introduced later. Enum constants are separated with commas. Since each enum is an instance of the enum class, they can be initialized. This is also very Java. Anonymous classes. Enum constants can also declare their own anonymous classes. Waiting and override function signal. What? Okay. Protocol state is an enum class and it has an abstract function signal. So waiting override function signal equals talking. Talking override function signal equals waiting. I don't know. Maybe this is some next state or with the corresponding methods as well as overriding base methods. Note that if the enum class defines any members, you need to separate the enum constants definition from the members definition with a semicolon, just like in, okay, you separate them with a semicolon. Oh, so these are the set of enums, and after the semicolon you can define some class defines any members. Implementing interfaces in enum classes. An enum class may implement an interface but not derive from a class. What? An enum class may implement an interface. Here. An interface. Okay. Implement interface but cannot derive from a class. Either a single interface member implementation for all of the entries or separate one of each entry point. So it can override these, apply as int, and I think that's binary operator, and you can provide two applies, and you also can have a default implementation of int binary operator. And working with enum constants, just like Java, enum classes in Kotlin have synthetic methods allowing to list the defined enum constants. Yeah, that's values and values of. So with the name, we can use a string, provide a string which is the enum name, and use value of, and we can get the enum class. And we can also get the array of enum class by values. In a generic way. What? Okay, so if we provide some function that takes enum of t, then we can what is this reft? What's that? No, not dictionary.com. Actually, I don't know how to pronounce this. Reified.
Reified.
Reified. Okay. Reified type parameters. Okay, that's class of T. What? I don't get it at all. Reified T. We changed from function of T to reified T, and we don't take the class type anymore. And okay. Ha. That's insane, but I think this may be helpful to something that I just recently reviewed. What we actually want is simply pass the type of this function. Here we walk up a tree and use reflection to check if a node has a certain type. It's all fine, but the cost side is not very pretty. What we actually want is simply pass the type to this function, i.e. call it like this. So reified T means okay. So the point is, if we want to pass some class, I mean, if we want to do something like reflection or to determine if this class is an instance of something in runtime, we can suppress this on-check cast by using a reified T. I think I'm going to use this directly in my work tomorrow because recently I just wanted to remove this suppress, but I failed too. Okay, so where were we? We were at Enum. So we can also use this reified T, which extends to enum of type T, and use the print of values. So we will definitely get a enum of T that we can get enum values of from. Okay, this is a little bit, this needs this is a little bit intermediate or even a little bit hard. I don't think if I get these thoroughly, so if I didn't, tell me more about, do tell me more in the chat or in the in a comment area of YouTube. So that's, I don't know if we have time for objects today. Objects looks like a big topic. Yeah, it does. So let's just keep it again and let's take a look at inline classes. Okay, this is big too. I don't think delegation is going to be small. Okay, it's actually small, but I don't want to jump so far away from where we were. So let's get a quick review of what we've learned today. Sealed class is a way that we can define a hierarchy of classes, and with that we can define subclasses that are basically independent of each other. And for nested class, we learned that and it's not the default inner class are like Java static classes which can access the outer classes. So if you want an inner class which works just like the Java way, you need to use the inner modifier. And to declare an anonymous inner classes, you can use the object keyword expression and enum classes. So basically, it's just like Java, the Java way, to me. That's my red. And you can implement interfaces in enums, which I never tried in Java. I'm not sure if this is possible in Java, but anyway, you can implement it in the in a specific enum or as a general enums in this enum class. Yeah, that's going to be all for today. So maybe we can write a problem, which I kind of believe would be easier for me now, because I'm a little bit tired of these. What's the word? Let me check. These these advanced features. Last night you partied a little too hard. Now there's a black and white photo of you that about to go viral. What? You can't let this ruin your reputations. You want to apply the box blur algorithm. I know this algorithm. You just use the use whatever due to its property of using equal weights. It can be implemented using a much simpler. So yeah, I think I haven't read this wiki yet, but I think it's using whatever in each pixel. It use whatever its upper and lower and blah blah, the 8 pixels that are around you. How about when it's on the verge? What if there is no top left or there is no bottom right? It does not say any of it. Oh, actually, there's no such condition because it's actually a mirrored or downsampled size, which is kinda different to what I expected. It is downsampling 9 pixels into 1 pixel, so the dimension is reduced by 2. So basically for a 3 times 3 you get a 1, and for a 4 times 4 you get a 2 times 2. Okay, so that means we can simply have an multiple list of integer which takes these, take these, and take these, and take these. So to do it really naively, we can just do the accumulation. but because there are some properties that we can reuse, like for if we have already calculated this, we can use it to calculate this by this 3 times 3 by adding these 3 and deducing these 3. Thank you for finally noticing that I am back. Anyway, so for each item we can just calculate a little bit less. Is there something we can improve even more? I believe so. Yeah, I kind of believe we can improve it even more. Like maybe we can first calculate a core, which is these 4, and then we add these, or at least, but this is not usable. I mean, yeah, it's not that easy to reuse. Not that something that I can think of easily. So actually we know that we can calculate this plus this, this plus this plus this, or maybe we can sample the, I don't think that's working. Yeah, I don't think sampling too much is smart, but this is what I'm thinking. Maybe we can sample 2 times 2, which is the sum of these four items, and the sum of these 4 items and these 4 items. And when we want to calculate this block, we add these items by this item. We actually add these 4 items and minus no, that's not working. Yeah, that's not making things simpler. What about if we have the sum of these 3, these 3, this 3, and these 3, these 3, these 3, and these 3, and these 3, these 3, this 3, these 3, these 3? No. What about these 3 and these 3, and maybe these 3, those 3, this 3, these 3? Yeah, I think that's possible. This one is better. We first get the sum of this, this, and this, and then we get the sum of this, this, and this, and this, and this, and this, and this, and then this, and this. And when we're calculating this, and this, we can simply calculate it by these 3 minus 1 and plus minus 7 and plus 1. So that's the fastest algorithm I can think of now, but maybe there are some faster ones. let's see. So, right, I think I've explained everything that I want to write already. And sadly, time's up. So that's all for today. We're going to write this problem tomorrow. See you tomorrow then. Bye bye. Actually, I should have said that I will be off tomorrow, so see you the day after tomorrow, which will be this Friday. So bye bye, bye guys.